So moving on to question 2, part A, we have to simplify this algebraic expression. Now, we notice that, well, you have two terms in the numerator and two terms in the denominator. Therefore, we cannot cancel a term in the numerator with a term in the denominator. So this x squared here cannot cancel with this x squared down here. We'll have to find another method. Now, I notice that in the numerator, we have x squared and then have the 7x. So x is common to both terms in the numerator. Therefore, I can factorize the numerator. So I'll just put the numerator to the side like this, the x squared plus the 7x. And I know that x is common to both terms, so that will be the highest common factor. So I put the x like this, open brackets, divide x squared with x, or you can say x into x squared, you'll get x, plus x into 7x, the x's will cancel, I remain at 7. Close brackets. So this would be the numerator factorized. Now I could do the same thing for the denominator. But I notice that there's nothing common between the two terms in the denominator, only 1. So then what do I do here? Well, I recognize that we have x squared here and this 49 is 7 squared. And this is a subtraction sign. So that'll be difference of 2 squares. So looking at the denominator, we have x squared take away 49. And as I said, that'll be x squared take away 7 squared. Because 7 squared is 49. And which is the difference of 2 squares? So we'll have x plus 7 in brackets multiplied by x take away 7. So now I'm just going to write over the question. We have x squared plus 7x over x squared take away 49. And this would imply, so for my numerator, I factorized my numerator and I got this as the answer, x multiplied by x plus 7. So I'm writing this for the numerator. So I have x multiplied by x plus 7 as my numerator. And then for my denominator, we factorized this and we got, x plus 7 multiplied by x take away 7. So this will be over. And for my denominator, that works out to be x plus 7 multiplied by x take away 7. Now, we notice that we have something multiplied by something in the numerator and same thing in the denominator, something multiplied by something. Now watch this. In the numerator, I've seen the x plus 7 here, which is multiplied by the x. And in the denominator, I'm seeing that same x plus 7 was multiplied by x take away 7. Now, in this situation, we can cancel. So up here, when you had individual terms in the numerator, same thing in the denominator, remember terms are separated by plus or minus signs, you just cannot take one term and cancel it with the next term. But if I have something multiplied by something, I can use that to cancel. So essentially, this x plus 7 will cancel this x plus 7. So what you remain with is x in the numerator and x take away 7 on the denominator. So this would imply x over x take away 7. And this will be your answer to simplifying this expression. Now for part B, part 1, we want to find the value of r when we have x to the power 2 multiplied by x to the power 6 is equal to x to the power r. So I'm just going to write that over. X to the power 2 multiplied by x to the power 6 is equal to x to the power of r. And we know the x is called the base, and the 2 here will be the power or the index. And we know anytime the bases are the same, see x and x here, bases are the same, and we are multiplying, we'll simply add the powers. So this would imply x to the power 2 plus 6 is equal to x to the power of r, and 2 plus 6 is 8. So again, this would imply that we have x to the power of 8 is equal to x to the power of r. And now, since the two bases are the same and we have an equal sign, then that has to mean that, 8 is equal to r, or you could say r is equal to 8. So this implies that r is equal to 8. And this will be your answer. You have found the value of r. So moving on to question 2, part B, part 2, we want to find the value of s when s cubed is equal to 8. So if s cubed is equal to 8, it means s is equal to the cube root of 8. And we know 2 by 2 is 4, and 4 by 2 is 8. So the cube root of 8 will be 2. But we can use the calculator and solve it. So on my calculator, the cube root button is the second function of the x cube button. So I'll press second function first, then the x cube. You see the cube root comes up. Then I'll put 8, press equal, and I get 2. So therefore, that would imply that s is equal to 2. So now moving on to question 2 part C, we have the diagrams below show a triangle and a quadrilateral. So this is my triangle, and a quadrilateral is a 4-sided shape, so this is the quadrilateral. They say all angles are in degrees and are written in terms of A and OB. Now we know the interior angles of a triangle must add up to 180 degrees, and also the interior angles of any quadrilateral would add up to 360 degrees. So that for part 1, for the triangle, show that 2a plus 5b is equal to 171. So the only information we have here are the interior angles of the triangle, and we know they're supposed to add up to 180 degrees. So let's do that. So I'll have the a plus 2b plus the 3b plus the a plus 9, and that's supposed to add up to 180 degrees. Now what we could do is bring our like terms together. Now I know my a is looking like a 9, so I'll just shorten this here so it make it look like a A, and also this one so it looks like a A. So now what we'll have to do is bring our like terms together. So I have the a's here, I have the b's here, and I have this 9 as a constant, put this 180 as a constant as well. So we have the a with this positive a, then we have the positive 2b with this positive 3b, and of course we have the positive 9 with this 180, positive 180. So writing the like terms together, remember the sign in front of the number is part of the number. So we have positive a with positive a, then we have positive 2b with positive 3b. And now what I'll do is put the equal sign here, put the 180. And what I'll do, I'll transfer this positive 9 across the equal sign and will turn to negative 9. So I'll have negative 9 here. So now let's simplify. So a plus a is 2a. So we get 2a here. Then we have positive 2b plus 3b. That's positive 5b. And that'll be equal to, and of course 180 take away 9 is 171. So we'll have 171. And that's exactly what they have here. 2a plus 5b is equal to 171. Now, part 2 of the question they have for the quadrilateral, they want to show that 7a plus 8b is equal to 342. So again, same thing. All we have is the interior angles of the quadrilateral, and we know they're supposed to add up to 360. So I'm going to write 6a plus this 3a plus 2b plus this 3b take away 2a plus this 18 plus 3b. And that's supposed to be equal to, well, it's supposed to add up to 360 degrees. So again, I'll highlight my like terms, bring them together, simplify, and see what we get. So we have positive 6a here, we have positive 3a here, and here we have negative 2a. And that's it for the a's. Then I have positive 2b here, positive 3b, and positive 3b here again. And then for my constants, I have positive 18 and this 360, positive 360. So for my like terms, I have this 6a plus this 3a, take away this 2a. Then for the b's, we have positive 2b plus 3b plus this 3b here. And then all remaining now is the constants. So I'll transfer this positive 18 across the equal sign and turn negative 18. So I'll put this equal to 360 and transfer the positive 18 across and turn to negative 18. And now I'll simplify. So we have 6a plus 3a, that's 9a, and 9a take away 2a. So 9 take away 2 is 7. So we have 7a. Then we have 2b plus 3b, that's 5b. And 5b plus 3b again is 8b, positive 8b. So that's plus 8b. And that's equal to 360 take away 18 is 342. And this is exactly what they have here. And now this part 3 is the last part of question 2. So here we want to solve the pair of simultaneous equations in part 1 and part 2 to find the values of A and B. Of course, I want us to show all working. So let's go back. So in part 1, our equation is 2A plus 5B is equal to 171. Of course, we show that here. So here we have the equation from part 1, and we'll call that equation 1. Now going back to part 2, this is our equation here. 7A plus 8B is equal to 342. And we show that here. So this is our equation from part 2, and we'll call that equation 2. So now for this pair of simultaneous equations, we have options. We can use the elimination method. We can use the substitution method. We can even use matrices. All right, so I'm going to choose the elimination method to use here. So it's obvious that with the 2A and the 7A, I cannot eliminate the A as is. And with the 5B and the 8B, I cannot eliminate the B, put it like this. So what I have to do is multiply equations by a number so that I can either add or subtract to get rid of one of the variables being A and B. So what I'm going to do is say equation 1 multiply by, and I'm going to multiply by the 7 here. So I'm going to multiply everything in equation 1 by 7. So I'm going to have 2 by 7, and I'm going to get 14A. I'm going to have 5B by 7, and 5 7s are 35, so that's 35B. I'm going to put equal, and 171 by 7. So 171 multiplied by 7 is equal to 1,197. So we get 1,197. Then for equation 2, I'm going to multiply it by this number here, this 2. So I'm going to have equation 2 multiplied by 2. So everything in equation 2, I'm going to multiply by 2. So 2 by 7A is 14A. 2 by 8B, 2 by 8 is 16, so 16B. And 342 by 2. So I'm going to have 342 multiplied by 2. And I'll get 684. So that's 684. Now, notice we have 14A here and 14A. Both of them positive. So if I subtract, I will get 0 and eliminate the variable A. So I'm going to put my subtraction signs here. So now 14A take away 14A is 0. 0 is nothing, so you don't have to write anything. And now you'll say 35B take away 16B. So that's really working out 35 take away 16. So 35 take away 16 is equal to 19. So that'll give us positive 19B is equal to, and now we have this 1,197 take away 684. So we have 1,197 take away 684, and that's equal to 513. So I'll have 513. So now we have 19B is equal to 513. So we transfer the 19 across. The operation between 19 and B is multiplication. So we transfer it across into division. So we'll have B is equal to 513 divided by 19. So B is equal to, so we'll take that 513 and divide it by 19. And we get 27. So B is equal to 27. So now that we know that B is equal to 27, let's read these equations. 2A means 2 multiplied by A, plus 5B means 5 multiplied by B is equal to 171. So if I know the value of B, I can just multiply this 5 by the value of B, and I'll get a number here. And the only variable, the only thing missing would be the A, which I can solve for. Same thing down here. 7A means 7 multiplied by A, which I don't know A, but the 8B means 8 multiplied by B. and I know the value of b. So looking at the two equations, I'm just looking for one of the better numbers, and equation 1 looks better because the number is smaller. So I'll go with equation 1. So I'm going to substitute b is equal to 27 into equation 1. So equation 1 reads, that's this 2a plus 5b is equal to 171. So 2a plus 5b is equal to 171. So again, we do know the value of a. That's what we're trying to find here now. So we have 2a plus 5b, and 5b means 5 multiplied by b. So we have 5 multiplied by 27, because b is equal to 27, is equal to 171. So we'll have 2a plus, and we work out what is 5 multiplied by 27, and we get 135. So we have 135 here, is equal to 171. So now we just transfer this 135, this positive 135 across the equal sign, and we'll turn to negative 135. So we have 2a is equal to 171, take away 135. So 171 take away 135 is equal to 36. So we're going to have 2a is equal to 36. And again, the 2 is being multiplied by the a, so we transfer 2 across. The operation will change to division, the opposite of multiplication. So we'll have a is equal to 36 divided by 2. So 36 divided by 2 will be 18. So a will be equal to 18. So we just come here and write the answers. So we have a is equal to 18. And we have b is equal to 27. And this will bring us to the end of question 2 and the end of this video. So look out for the next video, which will be on question 3.